Hello everyone, my name is Feiqi Huang. I'm very glad to have the chance to give you a lecture about the decision tree. First, let's go through the classification. The classification is one of the most important data mining methods, and it's also widely used in marketing, business, of course including auditing. And let's talk about how the classification works. In the training data, the data contains observations whose class label is known. So generally, each observation can be characterized by X and Y. The X is a set of attributes, or you can also call it predictors, independent variables, and inputs of the model. So, for example, if your classification task is about a client, so the X may be some attributes about the client's personal information like age, gender, and annual income. And Y is a class label, and you can also call it response, dependent variable, and output. As an example I mentioned, your classification is about the customer, so maybe the class label is whether they will buy the car or they do not buy the car. And the task of the classification is to identify which of a set of categories a new observation belongs, and on the basis of the training set. Here I give you two examples of the classification. Each classification examples have the task, attribute set, and class label. So let's look at the first example. The first example's task is recognize the email message. Attribute sets is email subject, content, and sender. And what we want to do, find the class label for each email. It is spam or non-spam. And the second task is to recognize the customer's preference. Just regard yourself as a car dealer, and you have some valuable client information provided by the client, like age, annual income, living area, and the marital status. So what you want to know is the customer's preference. What they want to buy is a sports car, luxury car, or SUV. If you can successfully predict the client's preference, maybe your sales can be double or even triple the other dealers. Okay, let's have a big picture how the classification model works. First, you have a training set, which is presented here is the larger table. You have 10 different clients, and you have attribute 1, attribute 2, attribute 3, and then you have a class, which is labeled properly or correctly. Then you have some algorithms to do the learning process. After the learning process, you will get a model. And then you want to use this model, and you want to apply this model on the testing set. The testing set is the lower part of the table. It is almost the same as the testing set, but it has obviously and a very important difference. The class of the testing set is not known. You want to use this model learned from the training set to predict the class of each client in the testing set. Now let's go to the decision tree, which is our topic today. The decision tree is a hierarchy model for classification whereby the local region is identified in a sequence of recursive split in a smaller number of steps. And the decision tree is composed by two important variables. First is the internal decision node, and the second is the terminal leaves. And each decision node implements a test function on an attribute. For example, whether this client's annual income is larger than 100,000 or lower than 100,000. And this is a function on the attribute annual income. And each leaf represents a class label. For instance, the node only contains records belongs to one class. So it can be regarded as a leaf. And you can give this leaf a class label, which is the same as the records in the leaf. And then I'll give you an example of the decision tree. The left-hand side is our training set, which has 10 client information, and we have 3 different attributes: marital status, gender, and annual income. And the class is a car type, which is the client's preference. And based on the training set, we can build the decision tree model on the right-hand side. And you can see the blue circle is a decision node, which presents the function. For example, the first one is the client's material status. It is single or married. And the second one is the gender. Is it male or female? And the third one is the annual income. It is more than 100,000 or less than 100,000. Blue box is the leaf, so it will assign the class label. For example, if the material status is single, it will lead to a leaf, and all the records in the leaf will be assigned as sports car. The last slide, we talked about the model. How can we use this model to apply it on the testing set to predict the class of new customers? Let's go through it. For applying the model to the testing data, we should have a test data. For simplicity, we just have one more client, the client 11, and we have the attributes information like married, male, and annual income is 190,000. But we do not the car type, which car they prefer. So we should start from the root of the tree. First, we should look at the marital status. And we can see the marital status of this client is married. So we first go right. And then we should look at the gender. And we find the gender of the client is male. So in the next step, we go left. And at this level, we still cannot predict which car he will prefer. So we should based on the third attribute, which is annual income. And we found the annual income is 190,000, which is larger than the 100,000. So we found that this client may prefer the sports car. So we assigned the car type to sports car in the testing data. And this is how the model works to apply it on the tested data. After we have a general idea of how the decision tree model can apply it on the testing dataset. By the way, it is very easy to understand how the application works, but the most important part here is how can we build the decision tree model. And we have different algorithms. One of the earliest one is the Hunter algorithm, and then we have CARD, we have ID3, we have C4.5, which is the most popular one, and we have SLIQ and SPIMT. Also, we have a lot of different decision tree algorithms. And even now, a lot of researchers are trying to design more decision tree algorithms. So, the general structure of the Hunt algorithm is like this. First, we have a DT. DT is the set of training records that reach a node T. If the DT contains records only belong to the same class, for example class 1, then we should assign the node T as a leaf labeled as C1. If DT contains records belong to more than one class, and then an attribute test to split the DT into a smaller subset. Recursively applying this procedure to the subset, and that is how the Hunt algorithm works. So for example, we have 5 different clients who have attribute 1, attribute 2, attribute 3, and now we can see the class have more than one class because they have sports car and family car. So we should pick one of the attributes to split the DT into smaller subset. If the subset only have one class, we should assign them label, and if not, we just repeat it, do the same thing, but use different attributes. So we go to the design issue of decision tree. There are 2 general questions. First, how should training records be split? And we have method for specification test condition, and we should have measure for evaluating the goodness of a test condition. Also, another important question is how should the splitting procedure stop? The obvious answer is to stop splitting if all the records belong to the same class or all the records have identical attribute value. So we cannot split it, and we do not need to split it, so we stop. And the second issue is early termination. Early termination related to some complex concept, like the overfitting or underfitting, and it is related to the tree pruning. So we do not cover it by this lecture. But the topic about the early termination is very interesting. You can just Google it and you can get some general idea about it. So the methods for expressing the test condition is depend on the attribute types. For example, the binary, nominal, ordinal, and continuous. Also, the method is dependent on the number of ways to split it. We can have a 2-way split, which is also called the binary split, and also we can have a multi-way to split it. Here we have the test condition for nominal attributes. If we want to the 2-way split, we just divide the values into 2 subsets, but we need to find the optimal partitionings. For example, for the attribute marital status, we can divide it in 2 parts. The first is single and divorced, and the second part is married. Also, we can put the single records in one group and the divorced and married in another group. And we need to find which one is the optimal split of this attribute. And the second is we have multi-way split. Just use as many partitions as distinct value. So here we have 3-way split. We have single group, we have divorced subset, we have a married subset. And for the ordinal attributes, there is a little difference. Also, we have the 2-way split. Just divide the value into 2 subsets and need to find the optimal partitioning at the nominal attributes. But another important issue for the ordinal attributes is we need to preserve the order property among the attributes. Let's see example. First is the size. We can split into 2 subsets. The first subset has a small and medium, and the second subset has large. So it works well. But the second example is the first subset is medium, but the second subset is small and large. However, it doesn't work because it violates the order property of the attribute. And also we can have the multi-way split. Just split the size into 3 subsets, small, medium, and large. And when we have the continuous attributes, still we have these 2 ways. First, 2-way split, binary split. We can just find a cutoff amount and find the 2 subsets. For example, for the annual income, we can find the cutoff amount 100,000. So the first subset is annual income lower than the 100,000, and the second subset is annual income larger than 100,000. And also we can have the multi-way split, but we need to find 2 cutoff amount. The first subset is annual income lower than the 80,000, and the second is the annual income between the 80,000 and the 120,000, and the third subset is the annual income larger than 120,000. But the trick here is how to find the best cutoff. How do you know the 100,000 should be the best cutoff for the two-way split, and the 80,000 and 120,000 should be the best cutoff for the three-way split? Maybe the little difference on the cutoff will significantly influence the performance of the decision tree. And that is the difficult part, to find best cutoff value. And next part, I will show you how to determine, how to find the best split. Just example here, we have the table, which is the training set. Still, we have 10 different client records. We have 3 attributes: marital status, gender, income, and we have the correct class. So before the splitting, we have 4 records belong to class 1 and 6 records belong to class 2. And we should find the attribute to split it. First, we choose a marital status. So we can divide it in 2 subsets by single and married. So for the single, we have 4 persons, and none of them belong to class 1 and 4 of them belong to class 2. And for the married group, we have 6 people. 4 of them belong to class 1 and 2 of them belong to class 2. And also, we can use gender to split it. For the male, we have 6 male, and 2 of them belong to class 1 and 4 of them belong to class 2. And we have the female, 2 of them belong to class 1 and 2 of them belong to class 2. And someone may wonder whether can we use the ID to split it. So we just did it. And because ID is a kind of identification, so everyone have a different ID. So of course, if you split by ID, each node have only one person, and this person will belong to class 1 or class 2 definitely. But can we use ID to split? The answer is no. Because the ID itself can bring no information to your model. The testing dataset and the training dataset should use different data. And the ID must be different for the training data and testing data. So basically, if you use ID to build the decision tree model, for the testing data, you cannot get any result. But still, we need to choose from the attributes marital status and gender. And how can we choose it? Which one is better? So the decision tree has a greedy approach. The nodes with pure class distribution are preferred. And we need a measure of the node impurity. We have 2 nodes here. The first has 4 records. None of them belongs to class 1 and 4 of them belongs to class 2, which has low degree of impurity. And the second node has 6 records. 4 of them belongs to class 1 and 2 of them belongs to class 2. So it should have higher degree of impurity than the first one. And here we introduce 3 popular measurements of the node impurity. The first is the Gini index, and the second is entropy, and the third one is a classification error. Do not scared by the mathematical functions, and the idea of the measure is very simple. So when the degree of the impurity is low or it is pure, the Gini index, entropy, and the classification error should be 0. And when the impurity degree is high, for instance, it is 50-50, we cannot even give a majority. So, which means the impurity degree is very, very high. So the Gini index, entropy, and the classification error should get the highest score. It is proved that the Gini index and the misclassification error is dominated by the entropy. So next, we only introduce the details of the entropy. The general idea behind all 3 measurements is the same. So if you understand how the entropy works, you should also understand how the Gini index and misclassification error works. Okay, measure of impurity, entropy. So the entropy at node T is captured by this function. And the PIT here is the ratio of the number of class I in the node T. It is the frequency of the records belongs to class I divided by the total number of the records in node T. You can see this chart. It shows when the P equal to 0 or the P equal to 1, which means the degree of the impurity is low, or we can say it is pure. So the entropy value is 0. And when the P equal to 0.5, which is a 50-50 situation, it has the highest impurity degree, so the entropy score is 1. Let's consider how we compute the entropy of a single node. For example, we have the node T1 and we have the node T2. For the node T1, we have 6 records. None of them is belong class 1 and 6 of them is belong class 2. The degree of the imp should be 0, right? Let's see whether it is 0. And the PC1T1 is 0 divided by 6. It's 0. And the PC2T1 is 6 divided by 6. It's 1. So the entropy is minus 0 times log of 0 to base 2 minus 1 times log of 1 to base 2, and it is equal to 0. And for the node T2, we also have 6 records, but 2 of them belongs class 1 and 4 of them belongs class 2. The degree of the impurity is higher. And the PC1T2 equals 2 divided by 6, and it equal to 1/3. And the PC2T2 equals 4 divided by 6. It is 2/3. So the entropy is a minus 1/3 times log of 1/3 to base 2 minus 2/3 log of 2/3 to base 2, and equal to 0.92, which means it has a higher degree of impurity. And the next part is how can we compute the information gain, which is a very important value to choose the best split. The information gain equals the parents' entropy minus the children's entropy. In another word, it means the entropy before the splitting minus the entropy after the splitting. We just give you an example to understand it. For example, we have 12 records before the splitting, and 6 of them belongs to class 1 and 6 of them belongs to class 2. So it is 50-50 situation. The entropy should equal to 1. We use attribute 1 to split it. So after the splitting, we have 2 nodes. The first node contains 6 records, and none of them belongs class 2 and all of them belongs class 1. Another node also contains 6 records, and 4 of them belongs class 1 and 2 of them belongs class 2. For the first node, the entropy is 0, and for the second node, the entropy is 0.92. We need to do the weighted average for those 2 entropy, and we got the entropy after splitting is 0.46. So the gain is the parent's entropy, which equal to 1, minus the children's entropy, which is equal to 0.46. The gain is 0.56. Here is the general concept of how to find the best split. We have already gone through it. The first is compute the impurity measure P before splitting. And the second is compute the impurity measure M after splitting. And how can we calculate the M? First, compute the impurity measure of each child node, and then calculate the weighted average impurity of each children. So we got the M, and then we choose the attributes test condition that produce the highest gain, which equal to the P minus M. I just give you an example about how to compare the gains. Before the splitting, we have node it have some records belong to C1 and it have some records belong to C2. The measure of the impurity is P, or you can just regard it as an entropy. And we can use attribute 1 to split it. And after the split, we have two nodes. Measure of the impurity of node 1 is M11, and the measure of the impurity of second node is M12. After the weighted average, we can get measure of the impurity M1. And we can also use attribute 2 to split them. And we also got two nodes. The first node, the measure of the impurity is M21, and the second node, the measure of the impurity is M22. So after the weighted average, we got the measure of the impurity M2. And we should compare it again. First is P minus M1 and faces the P minus M2. We should choose the attribute whose gain is larger. The last part is the features of the decision trees. It has some desired features. First, it is inexpensive. It do not need much computational resource, and it do not require very advanced server. Second, is extremely fast compared with other algorithms like the neural network. Now, I'm doing a research project dealing with more than 42 million clients' records. The goal of the project is also about classification. If I choose decision tree to build the model, it took me about 20 minutes to get the classification model. However, if I use neural network, the training time is more than 3 hours. Third, by the features, it is easy to interpret the trees because you can understand how they split the attributes. The cutoff is 10,000, 20,000, or 100,000. Fourth desired feature is accuracy. The accuracy of the decision tree is comparable to other advanced techniques like logistic regression, SOM, or neural network, but it do have some drawbacks. Basically, the decision tree is use a greedy approach. It only achieves the local optimal, but not global optimal. But some of the decision tree algorithms are trying to get the global optimal now. Okay, the last part is some in-class exercise. I provide two. The first one is to provide two examples of classification tasks related to auditing. And the second in-class exercise is consider the training example shown in the table for binary classification problem and answer the following questions. I think this question should not be difficult for you if you understand how the decision tree work, how the decision build, and how we can apply the decision tree. Thank you.